Given a string S, find the length of the longest substring without repeating characters. Okay, I think you know what it means by the longest substring, right? Substring is they need to be contiguous, like beside each other. So for example, SABC, ABC, BB, the longest without the repeating character is ABC. It cannot be ABCA. This has a duplicate of A. Yeah. For B, it's B. For PWKW, it's WKE, which is 3. It can't be WWK, you have a duplicate. It can't be this, you have a duplicate W. So I guess you have some idea how to solve this, right? Obviously, we can go to the brute force. You can find all the substring, this combination, and then from there you try to check if there's a duplicate, like, right? You could obviously use a hash set to track if the characters for each, and then you will probably have a result of n square solution, right? So yeah, so basically get all the substring. For each of the substring, you check if there's a duplicate, and that will usually result to n cube, or you can optimize this to n square. Every time you you move your j pointer and just store immediately to the hash, right, and see if there's you found a duplicate. You can go to that approach, and then maybe we'll try to optimize it. There's quite a number of ways to solve this using a linear time instead of like just getting all the substring and then trying to find if there's a duplicate within the substring. So to get all the substring, you normally have the two for loops here: I equals 0, len s I plus plus. Then you have another one for j. So obviously you start with I plus 1 because you're getting the substring, then len of s, and then j plus plus. And then you have a map to track all of your, just a boolean to see if it's already exists. Map int. Actually, when you do in Golang, when you do a index of the string, it's a byte. So this needs to be a byte. So what you can do here is, oh yeah, so sure, we can do something like this. HM is equal to hash map. And then for each time you see a character, you just simply append that to your map, like yeah, because you're starting with the index 0, and then okay, yeah, we should start from this one, from I. Yeah, sure. And then we store s j takes true, right? Then you put yeah, if it's not there, so you check this one. Okay, so score comma okay. If it's not okay, there's a duplicate. Yeah, and this one else, you assign it, and then you compute the max here, right? You compute the max, so you have the max var here, which is oh yeah, I have yeah, let's say finally just break out of this loop. So you start with the second pointer, and then max is if max is less than j minus I, and then assign max to j minus I, and then from here you just return max. Not sure if this is gonna work, but let's try it out. Define max. For max sets to int. Num-boolean for the condition. Num-boolean for the condition. I is less than len, then j is less than len. Basically, if you found something that is duplicate, you just basically remove that out. If it's not there, we assign, okay? Then we compute. If it's already there, it's the other way. That's the time we break out. So that's why we have it incorrectly. I think we need to put a +1 here, right? You need to put a +1 because j starts with 0. Okay, you need to put a +1, I think. I believe you have to put a +1 here. Not, if I'm not mistaken. Yeah. Then try to submit. It works, but it's very slow. Look at that. It's 469 milliseconds. There's 2 for loops here. It's an n-square solution. You're using one extra boolean to map. Okay, so how do we make this a linear, right? So if you look at this, you know that the longest substring is if there is no duplicate, right? So you can technically store all of them in the hash map in a single pass while you're moving. And if you see an let's take this for example, right? Yeah, so you can basically do a single pass like A, B, C, and then when you see an A, you know that you have to start from the last A. Basically remove this part, remove all the duplicates, right? So you just got this. Okay, and then you see a B. When you see a B, you know that you have to move this one forward, the B out. Then you have this, C, B, C, B. Then when you see a C, you remove this C and then it becomes like this, right? C, B, C, B, A. You know that there's a duplicate B inside. So what you need to do is remove A, remove B. So you got a CB. And then from B, what you need to do is remove CB and then you just get a B. So basically you have it's a 2-pointer solution where you did the last pointer that's a pointer that tracks on the left and the other one on the right. So in this case, you just keep on adding the right A, go to the right A, B, C, and then you see an A. What you need to do is move the left pointer forward, right? So that it becomes BCA. And then BC, BB, right? And then you continue to move again the BCAB. Move I again. And then again, you see a duplicate. You know that within here there's a duplicate. So you need to move I forward. So it becomes CAB, CBB. So while you're doing that, where you're moving the window, it's like a sliding window. You need to keep track of the max to max length. So in this case, the answer is 3 because you're just computing the max length. Yeah, that's one way of doing that using a sliding window. Another way is instead of moving the pointer left and right, you can just immediately move the I to the J position, right? Because let's say if I see like if I got something like this, A, B, 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 and then B, C, D, E, F, G, and then D, right? So let's say you have another example like this. Just remove this. So you're moving forward. I don't see any duplicate, and that's why D. Instead of moving the I pointer slowly and slowly until you remove the D, you can immediately jump to the D and starts from here. Start from here, right? Start from where the last D is, because you know that there's already a repeating character before that. Yeah, so immediately you can just jump instead of moving the pointer slowly. But anyway, we can do both of the solution. Probably go with a sliding window, and then we can consider trying the other solution where you just immediately jump. So if you're doing the sliding window solution, you don't need to track the index because you can simply move the pointer from the left, right? But if you want to jump immediately to that repeating character, you need to track the index in the hash map. So yeah, we can probably go with the sliding window first. So sliding window, you do need two variables, which is I and J. And then basically for J is less than the length of your string, right? So yeah, first we need to assign it to the map, like hm.sj, assign it to true, right? Okay, let's put a if check here. If Okay, range. If it's not okay, if it's not there, you assign it. Else, you delete it. You delete the I. You don't delete the J. The J is the one that moves forward. So you could do a delete here. The way you delete in a key in Golang is like this: hashmap plus, and then your key, which is I, little I. By the way, after this, you move the J, and then you're removing the left now, which is I. Here. Every time there's a new character that was added, you have to compute the max. So if max is less than J minus I, you can just simply max is equal to J minus I, right? And then return max. Let's try it out. Okay, works. Yeah, it works. So this is a sliding window where you slowly move the I until the position where you cannot find a duplicate anymore. But there's a much more, like, I think a better approach wherein you can just simply just jump, right? Just immediately jump to D instead of trying to move A, B, C, D away. You can jump to D. So the way you do that is you need to use, instead of bool, you use an int. Okay. And then, okay, so use an int. If it's okay, let's remove this. Then you assign HMSJ assigned to true. Okay, sure. No, the index with the J, sure. And then we put the max here. Still need to compute the max. Still need to compute the max. Okay, from here we need to move I. Well, let's say, okay, let's say I found it. I found a duplicate. We need to move the I. So I is equal to the J position. Yeah, I found a duplicate, right? But you don't want to, like, you don't want to always assign it. You only assign it if it's I is less than, because you want to always get the max of the of it. So it's like this. Let's try it out. I think you might need to start with -1 for the I. Okay, time limit exceeded. We missed the J. Okay, J++. Okay, the Golang syntax like this. Okay, works. Try it out. Okay, so there's the problem, because if it's an empty character, so one character, it doesn't go here, right? Immediately goes here. So your I initially is 0, so J is also 0 minus 0 will give you a 0. So what you want is you start I with -1. Just assign it there to fix this. So that 0 minus -1 will give you 1 instead of -1. Okay, this is not allowed, so you have to do something like this. Or okay, submit. Yeah, it works. Is it faster? I'm not really sure. It varies actually. This one and the other solution is almost the same time, because they're in linear solutions, so won't really see much of the difference. It's just that there's a little bit optimized for some worst case scenario. The worst case scenario is what I'm gonna give you. GG. This is the worst case scenario, where you can just, because for this you will have something like 2 to the n, where n is the length of this, because you have to remove all of this until you see the repeating one. Instead of, when you know there's already a repeating one, you can simply just jump here from that index and move starting forward. Yeah. There is a case where it's a ABBA, right? The reason why I was using a max, you see that I'm trying to get the maximum, the last highest duplicate, right? We're basically trying to get the highest duplicate here, because let's say you got a B index is this, is the last duplicate. But when you see an A, the index of the last duplicate of A is here. And you don't want to go back at the position of A. You know that the last highest duplicate is B. So you start off with B instead of trying to go to A. So that's why there is a always get to the highest duplicate. Yeah. Yeah, so yeah, that's basically it. We basically went through all of the possible solution of this. Definitely can be done in linear time. I think this and the other with sliding window solution is both are fine. Yeah, this is more like the similar to cadence algorithm where you just immediately jump to the I and J, basically start on the last duplicate, which is much faster. Okay, I think that's it. So hi Sassy, you're watching. Sorry for not responding. Quite busy solving this out. Yeah. So yeah, if you enjoyed the video, hope you like it. Hit like and subscribe. Thank you for watching.